Good evening my friends, welcome to session 4 of 15 CV33 fluid mechanics. Today we will continue our discussion on the numericals which we were taking in the last time. The learning outcome of the module 1 is student will learn the fundamental properties of fluids and its applications, and also student will learn the hydrostatic laws and its application to practical problem solving. So, with this objective in mind, the module 1 takes to summarize today's formula which we are going to solve the problem. The first law is as usual Newton's law of viscosity, which says that shear stress is proportional to shear strain, and the formula is shear stress, the shear force divided by the area is equal to mu, which is the dynamic viscosity, and the velocity gradient du by dy. Most of the problem which we are discussing here, they go with a boundary condition of 0 in the bottom. So, u2 minus u1, it becomes only mu into u. Repeat, du takes the shape of u, which is the maximum velocity of the plate on the top, or in a ball bearing also it will be the maximum velocity on the tangential. At the same time, the gap dy, which is actually the y2 minus y1, y1 is the lowest value which is normally 0. So, this dy turns to y. So, make a note of it. We are going to apply the Newton's law of viscosity in the form tau is equal to mu into u by y as highlighted with the red box. Is it okay? The next definition is kinematic viscosity, which is nothing but the ratio of dynamic viscosity divided by density. The dimensions are meter square per second, and also if you have a rotating bearing with a RPM n, we convert the tangential velocity of that RPM. For example, you take this pen, you can show me here also. It is a pen actually, and it is a bearing, and it is rotating like this, right? It is rotating with a RPM n, and on the side there is a lubricating bearing. You may be thinking where we can visualize. You can visualize in the fan, you can visualize in the bicycle where it is moving, and in the center you have the oil which is actually helping us to reduce the friction. So, that RPM whatever n is there, whether it is a mixie, whether it is a cycle tire, whether it is a vehicle, whether it is a ball bearing in a machine, all together we convert that RPM n with the help of a formula called, you can see the formula again back, u is equal to pi into d n by 60, where pi is 22 by 7, d is the diameter of that particular shaft, and n is the RPM, rounds per minute. Okay. Now, the torque which is required to move the body with that RPM is calculated by shear force into radius. The torque required to move that particular body or to move in with that velocity or RPM, that shaft, we need shear force F into radius R. At the same time, we have one more definition which we have talked about, capillary rise and capillary drop based on the cohesion and adhesion of molecules. Hope you remember the animation which I showed you, the video I showed you. So, the capillary rise for water is given by the formula H is equal to 4 into surface tension into cos theta. This is the angle of contact between the air and water, or air or mercury. As I mentioned earlier also, for theta, for air and water we will take 0 degree or hardly 10 degrees. But when it comes to mercury and air, the value will be around 134 degree or 124 degree. You can work out cos 90 plus theta is minus sin theta. So, there will be a capillary drop for mercury and capillary rise for water. Gamma liquid is the specific weight of the liquid which is multiplied by the diameter of the tube. As I told you earlier also, higher the diameter, rise will be less, lower the diameter, rise will be high. Apart from this, we are trying to solve today problem on bulk modulus, which is given by K is equal to change in pressure divided by volumetric strain. I repeat, the bulk modulus K is given by, for a fluid, change in pressure delta P divided by delta V by V, which is also called volumetric strain, right. The other formula is excess pressure. The soap bubble, which as I mentioned, the change of pressure or excess pressure will be equal to 8 into surface tension divided by diameter of the bubble, okay. And for the water droplet, it will be 4 into surface tension value divided by D. So, these are the problems we are going to solve, but before I continue, I would like to again repeat 2-3 things here. You can see here, note down the given data, note down the given data in any numerical, okay. You will list out 1, 2, 3 which is given, convert the data into corresponding SI units, convert the data into corresponding SI units, and last time also we practiced, you remember, diameter is given say 200 mm. I will divide that 200 mm divided by 1000 to make it to meters. Suppose we have taken a problem on liters, so it need to be converted to meter cube by dividing 1000. So, all those things are required. Suppose if I give dynamic viscosity mu in poise, you divide that by 10 to convert into Pascal second per square, okay. At the same time, third one, write the formula for the objective and substitute the value SI units into the objective. It means these 5 points are equally important to solve a problem. First one, we will note down the given data. Second, we will convert into the corresponding SI units. Third, we will write down the formula for the objective, and fourth one, we are going to solve the problem as per the requirement. Is it okay? Now, one thing is clear, that all these steps which I am discussing here are equally important to solve a numerical, right. Is it okay? So, one thing is very clear, to solve a numerical we need to identify the given data, convert to SI units, identify the objective, write the formula for the objective, and substitute in the formula all the SI components. Is it okay? Right. Now, let us come back. I would like to discuss one small thing before I continue. You can see in the diagram a plate of weight W on an inclined plane of say 45 degree is given. It means there is an inclined plane like this, around 45 degree it is there, and the weight W will be acting downwards exactly like this, right. You can see here it will be perpendicular. Can you see that plate W? Now, I would like to know in the plate and this particular oil or the fluid, and this is the inclined plane, what is the component which makes this plate to move downwards? That is number 1. What is the resistance offered by this liquid which is available here, right. So, if you see that this vertical W, which is the weight of the plate, like exactly like this particular box which I am showing you, it has got its own weight, say 20 gram example. So, this 20 gram, this angle is say 45 degree. Now, this particular component which will make it to move is W sin theta, right. And one more component is there, you can see here I am showing by the cursor, W cos theta. So, this angle is 45 degree, this is sine part, this is the cos part. It means if a plate is moving on a fluid exactly in my hand exactly, right. So, W sin theta is responsible for plate movement. I repeat with the cursor, W sin 45 is responsible for the plate movement. Is it okay? Now, let us take the first problem. Now, this problem on viscosity, a plate of 0.025 mm distance from a fixed plate moves at 50 centimeters per second and requires a force of 1.471 Newton to maintain this speed. Repeat, a plate of 0.025 mm distant from fixed plate moves at a 50 centimeters per second and requires a force of 1.471 Newton to maintain this speed. Question is, determine the fluid viscosity between the plates. It means exactly like this is a plate and it is having a force of 1.471 to maintain a speed of 50 centimeters per second this direction, correct. Now, first of all, as I mentioned, area is not given for the plate, we assume area of the plate as 1 meter square. Number 1. Number 2, given is the spacing between the plate, the oil film. It is very small. You can see it is hardly 0.025 mm, 0.025 mm. So note down dy is equal to 0.025 mm. Okay. Now next you see the plate is moving, plate of area 1 meter square is moving at a speed of 50 centimeters per second. It means the top velocity at the plate is du is 50 centimeters per second, and we need force of 1.471 to move this plate at that speed. Is it okay? So what will be first aim of ours? As I mentioned on the board also, you can see we are going to convert the plate units, that gap 0.025 mm to meter. How we will do that? You are correct, we are going to divide it by 1000. So 0.025 divided by 1000. So that will make value as 0.4025 meters. At the same time, the velocity is not given in SI system. You know very well, the velocity unit is meter per second. So 50 centimeters per second is going to be converted to 50 by 100, and the value will be 0.5 meters per second. So I hope by this time you are ready for these two with these two conversion and continue the problem. Now let us see what is the formula. The formula which we are going to use for the objective is Newton's law of viscosity. The formula is tau is equal to mu into du by dy. Now you can see here, as I mentioned, du is on the top of the plate 50, at the point it is 0, like a triangular. If you want, I can show on the board, exactly like this. This is 0, you can see here, this is 0 here at the bottom of the plate here, and the plate is moving with that velocity, and this is the gap. The gap is given as 0.025 mm. So we assume a linear velocity in this case, and the top velocity is 0.5 meters per second. So you have understood what exactly I am saying. This is exactly the plate moving here with 0.5 meters per second, okay, and here it is 0. So what is the u2? U2 is 0.5 meters per second, and what is u1? It is 0. So we say u2 minus u1 is nothing but directly du as 0.5. At the same time, you can see dy, the value is 0.025 mm. So the same thing is mentioned here. We will go back to the formula. Now we see tau is equal to mu into u by y. Now mu into u is the velocity 0.5, y is substituted in the proper unit, and shear stress. But shear stress is nothing but shear force is equal to shear stress into area. Shear force, whatever I am applying, because as we mentioned, a force of 1.471 Newton is required to maintain this velocity. It means this force value I know, 1.471. Shear stress I do not know, but the area of the plate, it means if this is moving with this one, this is a top area. I can show this way. Okay, this is moving with 50 centimeters per second, and this top area is 1 by 1. Correct. So when we multiply that value, tau into 1 is equal to mu into 0.5 divided by the gap. If you calculate, you get the value of 7.355 10 to power minus 5 as the answer for the dynamic viscosity. Is it okay? If you want to convert it to poise, you just multiply by 10, you get in the poise. You want to convert into centipoise, you multiply by 1000, you get the answer. Is it okay? So we go to the next question. Next question again on the viscosity. This question is again very interesting. A flat plate weighing 0.45 kilonewton has a surface area of 0.1 meter square. Okay, assume that this is a flat plate and it is having 0.45 kilonewton weight. Okay, kilonewton you know very well, we will multiply by 1000. Yes, you are right. it is a incline with an angle of 30 degree. So as I mentioned in the previous explanation, W sin theta will be responsible for movement, correct? What is the W? 0.45 kN. What is theta? It is 30 degree. So 0.45 into sin 30 will be responsible down the inclined plane. Is it okay? Let us continue. It slides down an inclined plane at 30 degree to the horizontal at a constant speed of 3 meters per second. If the inclined plane is lubricated with an oil of viscosity 1 poise, he has given you the dynamic viscosity between the plate and the inclined plane. That viscosity is 1 poise. Find the thickness of the fluid viscosity between the plate. This time he is asking you y to be determined. Let us see the diagram very nicely. You can see the plate is here, correct? Its weight is 0.45 kilonewton. Please multiply 0.45 into 1000, you will get 450, correct? So 450 Newton is the weight, 30 degree is the angle of inclination, and velocity is 3 meters per second, and this gap we need to determine. Question is understood? I repeat, this plate weight is given, angle is 30, it is moving with a velocity of 3 meters per second, and the gap between oil gap between the plate and the inclined plane is being asked. Is it okay? Diagram carries equal importance. Don't feel that you can directly apply the formula and get the answer. No, please draw diagram, it carries marks. Now we will go in the same style. Given u is equal to 3 meters per second, area of the plate, earlier you remember we assumed 1 meter square, correct? This time the value is given to you as 0.1 meter square. The viscosity mu is given in 1 poise. What we will do, my dear friends? We will divide it by 10. So we divide by 10, 1 divided by 10 will be 0.1 Newton second per meter square. Use your calculator whenever I am saying that you please convert this. Is it okay? So that you will be happy, then you will be also carrying with me mechanically. Now weight is 0.45 kN, 0.45 into 1000, 450 Newton. Weight along the incline, as I mentioned earlier also, if W is the weight, W sin theta will carry this side. So 450 into sine of the angle. What is the angle given in the question? Cursor you can see it is 30 degree. In the diagram also you can see it is 30 degree. So the weight along the incline which is responsible for the movement of the plate is 450 into sine 30. I think everybody knows sine 30 is 1 by 2. So 450 by 2 is 225 Newton is the force actually which is moving this plate on that particular oil or whatever liquid is there with a velocity of 3 meters per second. Now what is our objective? We need to find the thickness of the fluid between the plates. So what is the formula? Same formula. We have the Newton's law of viscosity. I need not explain to you again. Tau is the shear stress, force upon area. Force responsible for the movement of this particular plate down the inclined plane is W sin theta, which is known, divided by the area of the plate is equal to mu into du by dy. This formula again changes to mu into, instead of du I write u, instead of dy I write y, because there is a triangular variation and maximum velocity is u, maximum gap is y. Substitute the values one by one very carefully. You can see here it is 225 W sin theta, which is you can see here, which is substituted here. Area of the plate is mentioned here in the cursor, you can see 0.1 you take here is equal to mu, which is the dynamic viscosity. My dear friend, 1 poise is 0.1 Newton second per meter square as we converted, and du is 3 minus 0, 3 meters per second. See, you can see here the velocity. So 3 minus 0 divided by y, which is a unknown, minus 0. If you solve this, my dear friends, you get y is equal to, in mm, 0.133. I know that you may be thinking I am a bit fast. Do nothing, again substitute. I repeat the steps so that you can substitute and get the answer. W sin theta 225, area 0.1, mu 0.1, velocity change 3 minus 0, gap change y minus 0. So, if you solve this for y, you are going to get in meters, do not think, then you multiply by 1000, you get 0.133. So, is it okay? It is also a very beautiful question of university standard, in which we are finding the gap of the oil or the liquid based on the weight, based on the angle of inclination, and based on the velocity. Is it okay? Right. Let us take one more problem. This problem is slightly different. We will start, I will read out the question. It is a very interesting question. The velocity distribution for flow over a flat plate is given. Any flat plate is given, the velocity distribution. This time it is not linear. I will go to the board now. You can see here the velocity distribution is not linear. It is varying with a second degree. This is your y and this is your u, right. So, you can see here u is a function of y, but not linear. It is not linear, it is a second degree equation, right. U is the maximum velocity, u here and y here. So, like this, correct. Come back. So, you understood that sometimes we cannot assume the velocity distribution over the flat plate which we are moving here is not linear. Earlier we have taken linear velocity like this, maximum velocity was 50 centimeter per second and z is 0 here. Now, it is not, equation is given, you can see here u is given, u is equal to 0.75 y minus y square. It is a second degree equation, correct. It is a second degree equation, not linear. Okay. Continue. In which u is the velocity in meters per second and distance y in meters, okay, above the plate. Determine the shear stress at y is equal to 0.15. He is asking you to calculate the shear stress at a distance of 0.15 meter. Given the dynamic viscosity of the fluid as 8.5 poise, or he has himself has divided 0.85 Pascal second. Whether the question is understood? He has given you a velocity distribution for a flat plate, right. It is a parabolic, correct. He is asking you what is the shear stress. Now, you may be thinking, what is this question? This question is very interesting, you may be knowing differentiation, right. So, if you see the formula, tau is equal to mu into du by dy, they want du by dy need to be obtained. That is the reason I have put a note. You can also note down with your pen or pencil, make a note that we have to get du by dy by this formula. What you have to do? You have to differentiate the velocity distribution formula with respect to the distance du by dy, which will be, I will write here, tau is equal to mu into du by dy, 0.85 as given here. You can see the dynamic viscosity of the oil into du by dy. I can see here with the cursor d by dy of the u. What is u value? Beta? U value is 0.75 y minus y square. Now, you can see, you can differentiate that. If you differentiate 0.75 y with respect to y, it will be 0.75, y square will be differentiated as minus 2y. This is a critical step for the shear stress determination. So, we get a general equation 0.85 into bracket 0.75 minus 2y. This is the shear stress distribution, but he is not asking you to determine the general equation for tau. He is asking you, please determine the shear stress at, 0.15 meter. He is asking you to calculate the shear stress at an intermediate point. Agreed? Right. Now, we write shear stress tau at y is equal to 0.15 meter. I designate as tau bracket y is equal to 0.15 in the subscript is given by, when I substitute in this equation, y is equal to 0.15. I repeat again, the shear stress at 0.15 can be obtained by substituting the value of y in this equation as 0.15 or at the desired point wherever is given. So, let us substitute that 0.85 as it is 0.85, this value is 0.75, again 0.75 minus 2 into distance the value of y, which is 0.15. So, you can see here, if you substitute this and solve, you get the shear stress of 0.3825 Newton per meter square. So, this is totally a different equation, different problem in which we are supposed to get du by dy. That is the reason I have highlighted this point, because we have not done this earlier, because it is a non-linear velocity distribution. If it is a linear, we have no problem. I will write du by dy as u by y, as you know very well, correct. So, this time it is du by dy because it is a non-linear value. Is it okay? Now, let us go to the next problem. In the next problem, it is again a plate problem. I think more or less we have discussed. This time I would like you to take the lead and do this problem. Let us read the statement of the problem. A plate having an area of 1 meter square, a plate having an area of 1 meter square is moving down an inclined plane at 45 degree. It means same thing, a plate having an area, this to this is 1 meter square, correct, this to this is 1 meter square, and it is moving with an inclination of 45 degree. He has given you the velocity. Let us continue the statement. With a velocity of 0.75 meters per second due to its own weight. That is a beautiful statement. He is saying that because of its own weight, it is moving on an inclined plate of 45 degree, having an area of 1 meter square on the top, and velocity is 0.75. Let us, okay, due to its own weight. There is a cushion of liquid 2 mm thick between the inclined plane and the plate. There is a cushion of 2 mm thick. It means he is giving the gap. Now, please come to the diagram. You can see the diagram. Plate is here having an area of 1 meter square. This plate is moving with a velocity of 0.75 meters per second. The gap is 2 mm. You can see the value is written in SI system, 2 into 10 to the power minus 3. W is the weight he has not given, 45 degree. Definitely if I say W, you may be thinking, sir, there will be two component, one is W cos theta and one is W sin theta. Very correct. The W sin theta will be responsible for movement of this plate with a velocity of 0.75 meters per second. I repeat, the W sin theta will be the weight responsible for this plate to move with a velocity of 0.75 meters per second with a gap of 2 mm of the fluid which is available. Is it okay? Now, let us go back. There is a cushion of liquid 2 mm thick between the inclined plane and the plate. If viscosity of the oil which is given here is 0.1 Pascal second, find the weight of the plate. So, this time the question is asked for the weight. He has already given you the viscosity also. Nice. Let us first of all see what are the parameters given. Same diagram I showed you, W here, W cos theta and W sin 45. Is it okay? Given dy is the gap which is given as 2 mm. 2 mm divided by 1000, I will convert to SI system. Mu, fortunately he has given you in Pascal second, which is direct, 0.1 Newton second per meter square. Change in velocity, assuming 0 velocity at the bottom, means here the du is given as 0.75 meters per second. Area is 1 meter square. So, the weight of the plate along the incline which is responsible for the movement of the plate with this velocity of 0.75 meters per second is calculated as W sin 45. The value comes around W by root 2, or we can say 0.707 W. Is it okay? It means that this is the force which is moving the plate. This is the force 0.707 W which is moving this plate with a velocity of 0.75 meters per second. Is it okay? Let us see further. It is continued. Now you can see again I have just repeated, given we have converted to SI system. Assuming a linear velocity distribution in 2 mm oil film between the plate and the inclined plane. This is the oil film. So, here velocity will be 0, here will be the maximum, the value is given as 0.75. So, the shear stress is given by same formula, force upon the area, shear force upon the shear area, which is 0.707 as I mentioned. This W sin theta is responsible for the movement of the plate, and this is W by root 2, which value is 0.707 W divided by area, which is equated to mu into du by dy, which is again substituted as mu into u by y. Let us substitute the value, my dear friends. F is 0.707, area is 1. So, this remains as it is equal to mu in SI system 0.1 Pascal second square, then into u 0.75 meters per second, which is the velocity. You can see the plate velocity here 0.75 meters per second. Hence, diagram is very important. Then the gap, the y gap is 2 mm. You can see here 2 mm. We converted to SI units by dividing by 1000. So, 2 into 10 to the power minus 3, 2 into 10 to the power minus 3, and if you calculate that, the weight of the plate that you can always calculate before me, right? The weight of the plate is 53.04 newtons. So, this is a very good question in which a unknown weight has been asked for the plate which is moving with a velocity of 0.75 meters per second with an area of 1 meter square, having a 2 mm oil gap whose viscosity is 0. Newton second per meter square. Is it okay? Hopefully, we have you have almost understood how to tackle these inclined plate problems. Is it okay? Let us go to the next question. Let us slightly move from the flat plate to another one. Let us read the statement of the question. My dear friends, be ready with your calculator, be ready with your page and pen, mark the diagram whenever I am saying. A 150 mm diameter vertical cylinder, rotates concentrically inside another cylinder of 151 mm. It means outer cylinder is 151, inner is 150. You can assume that this is 150. So, it is rotating like this, exactly. So, you may be thinking this is outside is 151, inside is 150. So, the gap is hardly 1 mm, right. Now, both cylinders are 250 mm high. It means this length is 250 mm. Assuming that this is a cylinder of 250 mm length, diameter is 150 mm. It is moving inside, it is moving, you can see this is moving, and another cylinder is there outside which is having 151 mm. Is it okay? So, velocity here is maximum, outside is 0, correct? I repeat. Okay, I will show you the plan, I will show the diagram also, do not worry. Both cylinders are 250 mm high, it means this length of the cylinder is 250 mm. Okay. The space between the cylinder is filled with a liquid whose viscosity is unknown. It means, let us take this is better. Okay, this is moving with a cylindrical, this one with 100 rpm, you can see. Okay, outside one more cylinder is there. Okay, this is your 150 mm diameter, outside is 150 mm. You have a small oil gap, right, and the cylinder is 250 mm length, mind it well. Is it okay? Now continue the question. The space between the cylinders is filled with a liquid whose viscosity is unknown. We do not know the viscosity. He is giving you one term called if a torque of 12 Newton meter is required. It means when I am twisting this with a, say this is the force, I am twisting it with the force, the torque which I required to move with this RPM, okay, that mixer and all, we apply a force with the power, electric power, that is the torque. Okay. So 12 Newton meter is required to rotate the inner cylinder at 100 RPM. Determine the viscosity of the fluid. Okay. So the question is understood. There are two cylinders, one is static, stationary, outside with 150 mm diameter. Okay. One is moving, which is the inner one, exactly like a shaft, like I am showing by hand, 150 mm. It is filled with a liquid. He is asking you the viscosity, number one. Number two, it is we are requiring 12 Newton meter torque to move this with a RPM of 100 mm, 100 RPM, and the height is 250 mm. Is it okay? Let us see what is given. As I said, the gap will be 151 minus 150 by 2. I will show the diagram by 1000. The RPM is given as 100. The length of the cylinder is 250 mm. I will divide by 1000. You are right. Torque is 12 Newton meter. By using definition of the shear force, which we have done earlier also, F is equal to shear stress into area. Shear stress into area. Shear stress is given by Newton's law of viscosity. The formula is mu into du by dy. Okay. These cylinders can be modeled as flat plates with diameter d 150. Torque is given as 12 Newton meter, which is equal to shear force into radius. I repeat, torque is equal to 12 Newton meter is equal to F into R, and tangential velocity V is given by the formula pi dn by 60. Is it okay? Torque is 12 Newton meter, formula is F into R, and tangential velocity is V, which is pi dn by 60. He has not given you the velocity like previous case. Earlier, no, plate is to move like this, velocity is 1 meter per second, 0.75 meter per second. It is not the case, it is rotating. Okay. So I have to convert that RPM into linear velocity with this formula V is equal to pi into d into n by 60. Is it okay? The wetted surface, the whole length is wet, starting from the top of the cylinder to the bottom, 2 pi r into L. I repeat, 2 pi r is the circumference, length is the element. So everywhere it is wet, it is having an oil of some unknown viscosity, correct? So the wetted surface area is 2 pi r into L. Is it okay? Is it okay? Shall I repeat again? Okay. This can be modeled as flat plates with diameter 150 mm and outside is 150 mm. Torque is 12 Newton meter. Formula is shear force into radius. Tangential velocity V or U is equal to pi dn by 60. Diameter of the shaft is d. Wetted surface area 2 pi r into length L. Is it okay? So now let us see how we can see. I think I have shown the diagram. It will make you very clear. My dear friends, I request all of you to note on the diagram. First of all, you can see here, this is the inner one, the diameter is 150, this gap is dy and this gap is also dy. So this total is 151. You may be thinking, sir, this is 150 plus 2 dy. Answer is correct. I repeat, this is the inner one which is moving with a velocity like hand I am showing, RPM 100, and outer is 151. You can see, I will show with the cursor from here to here, from this point to this point is 151, from this to this is 150. So 150 plus dy plus dy, what is that? 151 is equal to 150 plus 2 dy. So we get the dy value based on that, correct? Okay. Now the velocity variation we are assuming as linear. You can see here maximum velocity is here, which is u is equal to pi d n by 60. You can see here pi d 0.15 into 100 divided by 60, because this is a rounds per minute. Minute is having 60 seconds, no, that division is there. So, pi into d 0.15 into 100 divided by 60. So, if you calculate, the value will come as 0.785 meter per second. Oil specific gravity is 0.9, 900 by 998, 0.9 is assumed, and we can see here the shear force tau into A is equal to mu into A into du by dr, which is nothing but torque by R. You remember, torque is equal to F into R. Torque is equal to F into R. So, F will be equal to torque by R. You are not correcting, I repeat. Torque is equal to shear force into radius. So, I say torque divided by R is equal to shear force F. Correct? We have to tune this particular given data to Newton's law of viscosity. We have to tune the given data to Newton's law of viscosity, which relates shear stress or shear force with the velocity variation. Correct? So, we say F is equal to shear stress into area, which is mu into A into du by di is equal to torque by R. Right? Now, mu into A 2 pi r L, which is the, I told no, 2 pi r is the circumference and L is the height. Right? So, 2 pi r into L. All those areas the viscosity will be there, because it is fully filled for a length of 250 mm for an area of 2 pi r. Correct? So, we say, we come back to our equation, mu into 2 pi r is 0.15, which is 150 mm, you know very well, into the length of the cylinder 0.25. Is it okay? Now, into du by dy. Du is 0.785, you can see on the top, u is equal to pi d n by 60. Du is 0.785 minus 0, and the gap which you have worked out from here, 150 is equal to 151 plus 2 dy. Dy is coming hardly 0.5 mm. Okay, that is going to be 0.5 divided by 1000, that will come 0.0005. Don't be in a hurry. 151 is equal to 150 plus 2 dy. 151 minus 150, you get only 1 mm, divided by 2, 0.5 mm, right? 0.5 divided by 1000, which is here as 0005. Substitute all the values. Please do it coolly and see that you get the viscosity of the given liquid. Is it okay? You can see the viscosity is 0.4324 Newton second per meter square or 0.43 poise. Is it okay? I know this question is slightly lengthy. I also know we are using extra equation. So, that is the reason I will just repeat in small formula you should remember. Okay? In this equation, we have understood one thing, we have to convert this system, Newton's law of viscosity, into shear force by multiplying by area. Shear force is given by torque upon radius, it is here, torque is equal to F into R. What is the F now? F will be equal to T by R. So, that is going to be here T by R is equal to mu into A into du by dy. What is the du? Which is pi d n by 60, and what is the area? Which is the 2 pi r this side, and length is the height of the cylinder, which is 2 pi r L. So, definitely this question has given you an idea how to solve a problem with a rotating cylinder. In this case, rotating cylinder is inside, stationary cylinder is outside. Is it okay? Sometimes, mind it my friends, it is going to be reverse. The outside cylinder will be rotating and inside will be stationary. So, slightly the values will be changing. So, these are the small question on the viscosity, they are very important. Is it okay? Now, we have travelled so much on the viscosity, you may be thinking almost I have solved some 5 to 6 problems on that. So, now we will take a simple problem on surface tension. A surface tension, you know very well, surface tension, tension at the surface. You remember that video, I showed a cup In that one blade was there and there was a tension of the membrane in which was not sinking because of the light weight, right. Now, let us take a question, read the statement. A soap bubble 5 centimeter in diameter contains a pressure in excess of atmosphere of 20.07 Newton per meter square. A soap bubble 5 centimeter in diameter contains a pressure in excess of atmosphere of 20.07 Newton per meter square. Calculate the tension in the soap film. So, definitely it is a very simple question. We will see how to solve this. In this question, for specific soap bubble, we have a formula delta P is equal to pressure inside minus pressure external is equal to 4 surface tension by R or 8 surface tension by D, both are same, right. Let us see what is given. Given is diameter of the soap bubble. The bubble is going like this in the air, 5 centimeter. So, what we will do, my dear friends, the 5 centimeter need to be divided by 100. Why? To convert to SI system. So, we get 5 divided by 100, we get 0.05 meter. Change in pressure or the excess pressure is given as 20.07. Okay. Now, we will see how is the formula. Delta P is equal to 4 sigma by R. Now, we need to calculate what is the surface tension of the film. So, delta P, which is given as in a big way, you can see 20.07, 20.07. R is actually D by 2. Mind it well, given is 5 centimeter diameter. I repeat, 5 centimeter diameter. The formula is asking you radius. So, do not be in a hurry in examination or in your test also. When he is given you in diameter, convert that diameter to radius by dividing by 2. So, 0.05 divided by 2 will give you 0.025 meter. Is it okay? So, be careful, sometimes they may give diameter, sometimes they may give radius, that you substitute directly. Let us see the formula. Formula says delta P is equal to 4 surface tension divided by R. Delta P is 20.07, you can see here. 4 surface tension value I do not know, and R is the value 0.025, which you have got by dividing by 2 to diameter. What is diameter? 0.05. So, when you do that and substitute, my dear friends, it is a simple number, you can mechanically work out the surface tension is coming between the tension of the bubble is 0.1254. You remember, I always reminded you, surface tension is a line force. I repeat, surface tension is a line force. The units are force per unit length. Pressure is a force upon area. Pressure is a force upon area, Newton by meter square. But surface tension is Newton per meter, force per unit length. So, you can see a small problem with the direct substitution of the formula. Is it okay? Let us see one more question on the surface tension. If the surface tension at air water interface is 0.075 Newton meter, it means he has given you the surface tension. What is the pressure between the inside and outside of an air bubble of diameter 0.009 mm? Very simple question. He is asking you what is the excess of pressure for the air bubble, right. The formula here, as I mentioned, Pi minus Pe 2 surface tension by R. What is given, my dear friends? You can see here surface tension is equal to 0.075 Newton per meter, as I mentioned, force per unit length. Diameter is given as 0.009 mm. What you will do, my friends? Yes, you will divide by 1000 to convert it to SI unit. So, 0.009 10 to the power minus 3, and air bubble has only one surface. Then hence delta P is equal to Pi minus Pe is equal to 2 surface tension by R. Substitute delta P is equal to 2 surface tension by R. Delta P I do not know, 2 surface tension force, you can see here 0.075, which is given, right. substitute here. R radius 0.0045, mind it well, this is diameter. Diameter is 2 times radius, correct. So, 0.0045 10 to power minus 3, if you substitute here, you get 33,333, or you can divide by 1000, you can make it kilonewton also. 33.33 kilonewton per meter square is the pressure, delta P. So, my dear friends, with this I close my today's session. Today we have almost completed all sorts of the problem which is there in the viscosity, right. We have repeated the class in the beginning with the formulae, and fortunately we have taken some part of the surface tension which are direct substitution problem, but main thing is you should take care for the units which I mentioned in the sequence also on the board. You can see, as I mentioned, you can see, note down the given data, convert into SI units, which we are doing it one by one. Note the objective of the question. For example, this question objective was delta P, then write the formula for that. Delta P is equal to 2 sigma by R, we have substituted, and substitute in the objective equation in SI units, so that there is no mistake, there is no problem. Is it okay? So, with this I again thank you for all your attention towards me. Thank you. See you in the next session.